Friends, today we will solve the problems based on superposition theorem. This category of problems includes independent and dependent sources. Here, the point to be remembered is dependent sources cannot be removed. As far as independent sources are concerned, we can remove those sources. For example, if voltage source is there, we can replace that voltage source by its internal resistance or internal impedance. Similarly, a current source can be replaced with its internal resistance or internal impedance. Problem statement is find voltage Vx using superposition theorem. So we have to determine the voltage drop across 4 ohm. So here I will mark the terminals as A and B. So in step number 1, we have to find the voltage Vx due to 50 volt source only. Meaning whatever the 100 volt source is there, that 100 volt source must be removed. That means that 100 volt source is replaced by short circuit. Let us use node analysis method. Let this point be X. Now potential at this point with respect to ground, let it be Vx. So you have Vx, which is the nodal voltage at node X, is nothing but Vx dash, where Vx dash is the voltage across 4 ohm when 50 volt source is considered. That means this Vx dash is nothing but V4 ohm corresponding to 50 volt supply only. Whatever the unknown current is there, so I will assume that current in this direction. So this unknown current I will assume like this one, whereas this is the known current, its direction is given like this one. So if it is say I, then if I apply the KCL, so two currents are leaving, so it is I1 plus I2. This is equal to incoming current, that is I3. So if we use the values, I1 is nothing but Vx minus 50 divided by 2 plus I2 is nothing but Vx minus 0 divided by 4, that is equal to 0.1 Vx dash. Okay, now since we have Vx is equal to Vx dash, here also I can place Vx dash. That means your equation is, if I take Vx dash common, so the first term is 1/2, second term here you have 1 by 4, and this 0.1 Vx dash I will transfer to left side. So this is equal to, so minus 50 by 2 is minus 25. I will take on this side, right side, it becomes 25. So this equation is Vx dash, so it is 0.5, 25 minus 0.1, that is equal to 25. So if I solve for Vx dash, that Vx dash comes out to be 38.46. Here, let this be equation number 1. That means this Vx dash is the voltage across 4 ohm when only one source 50 volt is considered. So in the next step, we have to calculate voltage Vx due to 100 volt supply. So again we will assume, say Vx double dash is the voltage across 4 ohm, so that is V4 ohm, when 100 volt supply is acting alone. Corresponding to this one, current is say leaving from the node, so this point is X. So this current is again say leaving from the node, whereas this is the current that is coming at point X. I write these currents are say I1, I2 and I3. Then so if we use the values, so let this potential is Vx. So your equation is Vx minus 0 by 2 plus Vx minus 100 by 4, that is equal to zero point 0.1 Vx double dash. Now Vx double dash is nothing but a drop across 4 ohm. So that drop is nothing but I current through 4 ohm, which we have assumed as I2 into 4 ohm, and value of I2 is Vx minus 100 by, so this value comes out to be, that is Vx double dash is equal to Vx minus 100, or Vx is equal to, so here if I write this to be say equation number 1 as far as step 2 is concerned, here say equation number 2, I will use equation number 2 in 1. So here the value is Vx by 2, so it is Vx double dash plus 100 by 2 plus Vx by 4, so that Vx by 4 is Vx double dash plus 100 by 4 minus 100 by 4, that is minus 25, is equal to zero point 0.1 Vx double dash. So again, if I take Vx double dash common, so it is 1/2 plus 1/4 minus 0.1, that is equal to, so 100 by 2, 100 by 4, so it is 50 minus 50, it is minus 25 plus 25. I will transfer this minus 25 on this side, so that becomes minus 50. Okay, that means this term, left side term, is Vx double dash equal to 0.5 plus 0.25 minus 0.1, that is equal to minus 50. And if you solve for Vx double dash, that means what we did is we have calculated voltage drop across 4 ohm when 100 volt battery is present. So in the third step, let us find the voltage Vx caused due to both the sources. So already we have calculated Vx dash. So Vx dash is nothing but the voltage across 4 ohm due to 50 volt source, and that value comes to be 38.46 volt. This thing we have calculated. Now Vx double dash, that is the voltage across 4 ohm due to 100 volt, that value we have calculated. That value is minus 76.92 volt. 8 point, calculate voltage drop across 30 ohm. So circuit includes 3 sources, 2 independent sources, 4 ampere and 60 volt, whereas 1 dependent source. So this source is current controlled current source. So in the first step, we will calculate voltage drop across 30 ohm when 4 ampere source is acting alone. That means whatever 60 volt source is there, that 60 volt source we have removed. So let us use this point as say A, this point is B, and we will apply the KCL at point A and B. So KCL at point A, so this current is incoming current, this current is already given, that is the outgoing current, so let this be outgoing current. So if you have say I1 here, I2 here and I3 here, then you have incoming current I1 is equal to the sum of outgoing currents I2 and I3. Let this be equation number 1. Let us use the values. I1 is 4, that is equal to, now your I2 is this current, that is nothing but I1 dash, plus I3 is current flowing through 10. So you have say this point is at potential VA, this point is at potential VB. So you have VA minus VB by 10. So if you solve this one, if you take the LCM as 10, so it is 40 is equal to 10 I1 dash plus VA minus VB. Let this be equation number 2. But value of I1 dash is given. So I1 dash is nothing but I 20 ohm. So this is nothing but potential VA divided by 20. So let this be equation number 3. So if I use equation 3 in equation 2, then the term comes out to be 40 is equal to 10 VA by 20 plus VA minus VB. So this value is, so it is VA by 2 plus VA minus VB, that is equal to 40. Or so this VA by 2 plus VA by 2, this is 3 by 2 VA, so it is 1.5 VA minus VB, that is equal to 40. Let this be equation number 4. Now if you apply the KCL at node B, then that KCL equation is, here I will use the KCL at node B. So let the current here is, this current is incoming already given, and unknown currents I will assume like this one, the currents that are leaving. So your equation is incoming current is 0.4 I1 dash and the two currents are leaving. So current through 10 is, for a direction leaving current, VB minus VA by 10 plus this current is VB minus 0 by 30. So if you multiply entire equation by 30, then that value comes to be 12 I1 dash, that is equal to 3 VB minus 3 VA plus VB. Okay, so just if we write this equation like this one, so that comes to be minus dash, let this be equation number 5. Now again I1 dash is given. So I1 dash is nothing but VA by 20. That means if I use equation 3 in 5, the equation becomes minus 3VA plus 4VB is equal to 12 VA by 20. Now if you simplify this equation, that comes to be minus 3VA, and this 12 by 20 minus 0.6 VA, I will transfer that on left side, plus 4 VB, that is equal to 0. Or this equation comes to be minus 3.6 VA plus 4 VB is equal to 0. Let this be equation number 6. That means what we have is two simultaneous equation. One equation is this one, 1.5 VA minus VB equal to 40, and this is equation number 6. So if I solve for VA and VB, so that VA comes out to be 66.66 volt, whereas VB comes out to be 60 volt. That means, now if we look here, the question is to find out voltage drop across 30 ohm. Now that voltage is with respect to ground. So that voltage Vx, the notation we have used as Vx dash, when 4 ampere source is acting alone, is nothing but Vb, that is equal to 60 volt. Let this be equation number 2. Now let us calculate the voltage across 30 ohm when 60 volt battery is acting alone. That means again if I use the node analysis method, so here I'll use say node X with potential as Vx. This current is say a current leaving from the node, This is the current leaving, whereas this direction is given. So essentially your Vx is nothing but Vx double dash. Okay, already this voltage is given. So if I use, say, this is I1, this is I2, this is I3. That means your equation is this current I1 and I2 are the current leaving, whereas I3 is the incoming current. So your equation is sum of currents that are leaving from the node is equal to sum of the current that are coming at the node. So I1 value is, I1 is current through this branch, so it is Vx, that is nothing but Vx double dash, Vx minus 60 divided by 30 plus this current now, so it is Vx by 30, that is equal to incoming current, it is 0.4 I1 double dash. Equation number 1 for the state 2. Now what are the I1 double dash is there? That I1 double dash is nothing but this current. Okay, that means current flowing through this branch. So I1 double dash is Vx minus 60 divided by 30. So if I use equation 2 in equation 1, what I am getting is Vx minus 60 by 30 plus Vx by 30 is equal to 0.4 in bracket Vx minus 60 by 30. Now that 30 gets cancelled, so your term comes out to be Vx minus 60 plus Vx is equal to 0.4 Vx minus, so this term comes out to be, so if you take Vx and this Vx, 2x, I will take Vx outside, so it is 1 plus 1 minus 0.4 is equal to minus 24 plus 60. And if we solve for Vx, that Vx comes out to be 22.5 volt. Now since Vx and Vx double dash that is same, so your Vx double dash is equal to voltage drop across 30 ohm. This is nothing but 22.5 volt. Okay, so this is your equation. Next, now if we use the superposition theorem, then by using superposition theorem, Vx dash already we have calculated, Vx dash, Vx double dash, that is 22.5 volt. So by using superposition theorem, Vx is equal to Vx dash plus Vx double dash, that comes out to be 82.5 volt. That means voltage. Problem statement is calculate current flowing through 6 ohm resistance using superposition theorem. That means here we have to calculate current flowing through 6 ohm resistance. So the circuit includes 3 sources, 2 independent voltage sources, 15 volt and 10 volt, whereas 1 current controlled current source. Now in the first step, let us calculate current I dash. So here notation we have used is I dash is nothing but I6 ohm when only one source is active, that is 15 volt. Corresponding to that, now here we will use the node analysis method. So if this point is at potential Vx, then the incoming currents are I dash and 3I dash, whereas that means your equation is I dash plus 3I dash, that is the incoming current, that is equal to outgoing current I. So 4I dash is equal to I, that I is nothing but Vx by 8. Whereas the value of I dash See, if we look at this point, so this point is at potential 15 volt, this point is at potential Vx. So potential difference divided by resistance. So 15 minus Vx by 6 is nothing but I dash. From equation, say I dash here is 15 minus Vx divided by 6. So if I use the value 15 minus 12.63 divided by 6, so this value comes out to be 0.395 ampere. And what are the direction is there? So if I put this points as A and B, so the direction is A to B. So let this be equation number 3 for this step. With this point at potential Vx, so incoming currents are I double dash and 3I double dash, whereas current leaving is here say I. So your equation is sum of incoming currents, so I double dash plus 3I double dash is equal to I. So 4I double dash is equal to, now current I is nothing but Vx minus 10 divided by 8. So that is nothing but Vx plus 10 by 8. Now the value of I double dash, so if we look here, so this point is at a reference potential of 0 volt. So current is flowing like this way. The current I double dash is equal to 0 minus Vx divided by 6. So if we use this value, V2 minus Vx by 6 is equal to Vx plus 10. Vx comes out to be minus 1.58 volt. Now our objective is to find out I double dash. So I double dash from equation 5, I double dash is equal to minus Vx by 6. So minus 1 by 6 into, so this value comes out to be 0.263 ampere. 0.263 ampere. That means this current is A2. In the final step, the current flowing through 6 ohm due to both the sources is equal to I dash. That means I 6 ohm is equal to I dash plus I 95. This value I double dash is 0.658 ampere.